Good morning everyone. Today we are going to do different forces, page 88, student book. Alright, I'm going to read. You can follow with me and you can highlight the important sentences or words. Friction is a force that exists between moving surfaces. Friction exists in liquids and gases too. So this is important. Friction not only exists in solids, it also exists in gases and liquids. We have seen last week about the air resistance and the water resistance. Okay? So air resistance is a force that slows down objects moving through air. Water resistance is a force that slows down objects moving through water. So you can highlight both these sentences. Air resistance is something that is a force that slows down moving objects through air, and water resistance is a force that slows down objects moving through water. Forces all around you. We live at the bottom of a sea of air. We are surrounded by invisible air. It presses down on us all the time. We can feel its force when the wind blows or when we move through it. We call this force air resistance. So air resistance is around us all the time, okay? Slowing down. A parachute slows down as it falls through the air because the air rubs against it. A parachute with a bigger canopy. Canopy means the cloth that opens up, that's the canopy, will fall slower than one with a small canopy. So if the canopy is big, the parachute will fall down slower. This is because there is a bigger surface area in contact with air, so there is more resistance. Okay, so since the area with air is more, it will fall down slower. Alright, streamlined shapes. Objects that have large flat shapes meet a lot of resistance in water. Fish and marine mammals have pointed slim body shapes to cut through the water. Their shapes reduce the water resistance. So a streamlined shape will cut across faster. It will resist or it will reduce the water resistance. That slows them down. We call these shapes streamlined. Okay, so you can highlight streamline. Streamlining is important in air too. The fastest sports car have narrow pointed streamlined shapes. The air passes quickly over them and reduces the amount of air resistance. So a sports car has a nice streamlined shape so that it can travel fast. It can cut through air and move fast because it's a sports car. It needs to win a race, so it has to move fast. Okay, so the shapes of sports cars are normally streamlined. Now fly a kite. Make some different shaped kites and fly them in a windy day. Which kites are easiest to control? What difference does the size of the kite make? Can you feel how hard you have to pull on your kite against the air pushing it up? So this is like a simple wind gauge, okay? And the wind blows on the flap and the thing moves, okay? Now sailors need to know the strength of wind to help them sail. Find out about Admiral Beaufort and his wind scale. Make a wind gauge to measure the force of the wind. Are your results the same as the local weather forecast? Use a digital recorder to record and play your own weather forecast. Alright. Now, normally if you were in school, Miss Shweta would ask you to do a project on the wind gauge. But since we are not at school and we are not at home, we are at home, I'm not going to do the project, but I do want you to look at the internet for a picture of the wind gauge and see how it is, and as homework you will just draw the wind gauge. Okay, all right, so find out more. More about friction in air and water and how parachutes work. The first kites were about 3000 years ago in China from silk and bamboo. In June 2000, a skydiver made a parachute jump from a height of 2 miles using a triangular shaped parachute designed in 1485. Lots of scientists thought it wouldn't work, but he glided to Earth quite safely. So normally, this is just extra information when which type of fabric was used to make kites, and also how the diver or a parachute used a parachute to jump from the height of 2 miles. All right.